In this video, we are going to talk a little bit about simplifying fractions. And in order to simplify fractions, we need one little rule, or a lemma. A lemma is just a math term for a little rule, because everyone needs their own little terms. And this lemma is actually called the fundamental principle of fractions. And the fundamental principle of fractions is pretty simple. It just states that if we have a times k in the numerator of a fraction, two numbers being multiplied together, and we have b times k, two other numbers being multiplied together, but they both include a k, if we have a times k over b times k, you can cancel out the k's and just end up with a over b. So a lot of the time when we're doing this algebra terminology with letters, you can't really understand what it's trying to say, but it will become very clear once we do a numerical example. For example, 12 over 21. If we have the fraction 12 over 21, then I know for a fact that these are not prime numbers. And if they're not prime numbers, what does that mean? It means they can be broken down. It means 12 can be written as, say, 3 times 4 in the numerator. And 21 can be written as, say, 3 times 7 in the denominator. And now you see that we have a k. We have something that's on the top and also on the bottom. In this case, it's these 3's. And what that means is if we have a 3 on the top and on the bottom, both being multiplied into a fraction, only multiplication, I can cross them off. So I can say 12 over 21 is equal to 4 over 7. Or 12 over 21 is equal to 4 over 7. And that's just how you simplify fractions. If we had, say, variables in our numbers, let's say we have 8a over 15a. Well, here I immediately see that there's an a on the top and an a on the bottom. So what I can do is cross the a's off right away. The a's in this case are my k's from up here. I have an a on the top and on the bottom, so I can cross them off. But I can go further in this case. I have 8 over 15. Well, do 8 and 15 have anything in common? Well, we can put 8 and 15 into the division box and say, are there any factors that we can pull out of both 8 and 15? And we think for a minute and we remember that 8 is just a bunch of 2's. And 15 doesn't have any 2's because it's odd. So 8a over 15a is just going to equal 8 over 15. And let's simplify one more fraction, put a few things together. Let's do negative 6ab over 39b. And we look at this one, and the first thing I notice is there's a b on the bottom and there's a b on the top. If we have the same thing on the top and the bottom, they can cancel. So this turns into negative 6a over 39. Now I still have an a on the top. This is a 9, not an a. It's just bad handwriting. I still have an a on the top, but I don't have an a on the bottom. So I know in my final solution I'm going to have an a on the top because it's not going to cancel. So now I look at the numbers. I look at 6 and 39. Do 6 and 39 share anything? If I throw them into the division box, 6 and 39, they do have something in common. I can pull out a 3. If I pull out a 3, 6 divided by 3 is 2. 39 divided by 3 is 13, or 3 times 13 is 39. And so I'm left with, if I pull that 3 out, I know that on the top I have, let's write it all out, all the steps. I have negative 3 times 2 up here. And down here I have 3 times 13. And what I can do is I can cancel these 3's. And I'm left with negative 2a over 13. So when you're simplifying fractions, all you have to do is take out anything the top has in common with the bottom, and then you can cross them out using the fundamental principle of fractions. And the last thing we have to talk about here is one more property. What to do with negative signs, because you saw a negative sign in the last answer and I didn't do anything with it. But there are certain circumstances that you might have to do something with the negative sign. And this property is negative a over b is equal to a over negative b. If you have one negative sign in a fraction, that whole fraction is negative. This is equal to negative a over b, negative the whole fraction. And one other part of this property is what if you have a negative on the top and the bottom? Well, if I have a negative on the top and the bottom, I can say this is equal to negative 1 times a over negative 1 times b. And just like how we had the k on the top and k on the bottom previously, we can now cross this off. We can cross these ones off, and we're left with just a over b. So our second half of the property is, if we have a negative on the top and a negative on the bottom, they cancel, and we end up with no negatives. So we'll do one more example. We'll do an example using that ties it all together. And let's do negative 3xyz over negative 8yz. So I'll start with the z's. I see a z on the top and a z on the bottom. So I know that this is going to be equal to negative 3xy over negative 8y. Now I see a y on the top and a y on the bottom. I can cross them off, and I'm left with negative 3x over negative 8. Now I see an x on the top, but there's no x on the bottom. So I know that I'm going to have an x left on the top, no matter what. Do 3 and 8 have anything in common? Well, one thing that we know is 3 is a prime number. 8 is not a prime number. 8 has no factors of 3 because it's even. Because it just doesn't have any factors of 3. Not because it's even, because the number 6 could have a factor of 3. Slip of the tongue. But 8 has no factors of 3, so we know for a fact that we're going to have 3 and 8 on the top and bottom. But we also have a negative sign here and a negative sign here. Since we have one on the top and the bottom, we can cross them off, and our final answer is just 3x over 8. So this is equal to our original negative 3xyz over negative 8yz. Thank you.